Hi friends, welcome to Code with Swiggy YouTube channel. So in this video, we're going to discuss about literals in Java. If you are very new to Java, then this term literal may be unfamiliar, so you don't need to worry. We're going to discuss about literals here. And before we get into this video, if you are new to our channel and if you are not aware of what we have discussed till date, so you don't need to worry. We always add all the links in the description, so please go ahead and have a look on the previous videos. And I recommend to watch part 1 video of data type so that it will be very easy to understand about the literals. Okay, because in that part 1 video I have discussed the numbers as whole numbers and fractional numbers to differentiate the data types. Okay, but we have to understand, like, is it really Java will term the numbers as whole numbers or a fractional numbers? If you ask this question, then no, Java will use the term literals to specify all these numbers. Okay, before we move into further, just we will discuss about what is exactly means literals. Okay, we all know the values is literals, so we can say like the fixed values will be called as literals. So if you want to say in a different way, assigning a fixed value to the primitive data types is called as literals. So say for example, so we used to assign the values, right? So for example, if it is a boolean, then what we will say, false or true, right? Okay, so say for example, if you want to take a character, we used to say, okay, fine. So if it is an integer, then we used to say, right? So if it is a float, we used to say, okay. So assigning this kind of values, okay, to these primitive data types is called as literals. Okay, so then what are all the literals we have in Java? Okay, we have integer literals, then floating point literals. Okay, if you take the number system, we have decimal value, and then we have octal value, and then we have hexadecimal value, and then we have binary value, right? So all these 4 type of numbers we need to handle, right? So this integer literal will talk about all these 4 types. Okay, the floating point literals will talk about, as we discussed earlier, it's going to talk about float and double only. Okay, fine. So now we will see one by one. Say for example, now we are going to discuss about integer literals. Integer literal, as I told, we have 4 types: decimal, then octal, then hexadecimal, then the last one will be binary. Okay. So we all know the decimal value will be specified with base 10 because we have the numbers from 0 to 9, right? So we have 10 numbers in the decimal representation, so that's the reason we are using base 10. Okay, fine. If it is octal, okay, then it will be specified with base 8, right? Octa means 8, so it will use the numbers from 0 to 7. Okay, so here we have 8 numbers in use, so that's the reason we are specifying base as 8. If it is a hexadecimal, okay, then we will specify the base as 16. Okay, fine. So if it is base as 16, then we should have the 15 numbers, right? So that 15 numbers will go from 0 to 9. Okay, we got 10 numbers, then A, B, C, D, E, F. So now we have total 16 numbers to use. That's the reason we are specifying it as base 16. If it is binary, obviously we all know, right? It will be a base 2. Okay, because we have 0 and 1, so we have only two numbers to use. That's the reason we are specifying it as base 2. Okay, fine. So to specify a decimal value, okay, you can very well specify like integer a equal to 10. Okay, if you want to specify a octal value, then you have to say integer b equal to 0. You have to append 0 and then you have to say the value. Okay, the same way if you want to specify hexadecimal, okay, integer c equal to, you have to append 0x. This may be a lower or uppercase. Okay, whatever you want you can use. Then you can say 0 3, like something like that. Okay, if you want to specify a binary, okay, integer d equal to 0b 101, like this. Okay, so if it is an integer, you can directly say 10. Okay, if it is a octal, you have to say 0 in front of the value. If it is a hexadecimal, you have to say 0x, or this one may be lowercase or uppercase, whatever you want you can use it. The same way, if you want to specify a binary, you have to specify it with 0b. Okay, that is, this may be lowercase or uppercase also. Okay, so this is how we have to specify the integer literals. Then we have to talk about floating point literals, right? Okay, float n equal to 0.735f. Okay, this is how we have to specify it. There is no change in the floating point representation, and as well as in double also there is no change. Double d equal to 0.394, something like this. Okay, but one thing here, what we can do is we can specify it in scientific notation also. So say for example, we have a value like double d equal to 132.72. Okay, we have a value something like this. Then you can specify this like 1.3272 e2, because we have moved 2 digits, so it is equivalent to 1.3272 into 10 square. Okay, so if you multiply it with 100, then obviously you will get 132.72, right? So this is how you can specify in double. Okay, so that's all about the literals. To summarize this, Java will not talk about whole number or a fractional number. So it has its own terms to specify that number. So those terms are called as integer literals and floating point literals, right? And it has 4 types in it: decimal, and then octal, and then hexadecimal, and then binary. Each and every one has its own representation. Okay, we have to use that representation to represent the values. Okay, the floating, there is no difference in the floating point and the double representation. Let's we get into Eclipse to see some examples. Okay, so as usual, I'm going to create a new project. Okay, data type literals project. Okay, I'm going to say finish, and then just do right click and create package com dot sample dot learning. Okay, fine. Just do right click and create class literals test. Okay, then just select that main method and then say finish. So I'm going to say literals is all about the values. Okay, so values in the sense we have 4 different values, so those are all decimal, octal, and then hexadecimal, and then last one is binary. So integer a equal to 10, or I can say decimal literal, okay, equal to 10. Then integer octal literal equal to 0, 10. Okay, so for example 18, okay, it will give you error, okay, because the 8 will not be used as an octal value. Okay, fine, we all know, right? The range is from 0 to 7 only, so that's the reason you have to use 7 here. Okay, this is how you can specify it. So the next one is integer hexadecimal. So I'm going to say 0x. Okay, we can use 1a 2 like this. Okay, but you cannot use 0x, so we can use still f, right? If I use g, it will give you an error. So if I say f till f, you will not get any error. So what is the value? 0 to 9 and a to f. Okay, technically speaking, it will deal from 0 to 15. Okay, 0 to 15. So to represent from 10, we will use the alphabets A to F. Okay, so here A will take 10, then B will take 11, then C will take 12, then D will take 13, then E will take 14, F will take 15. That's all. Here we have 15 values, so that's the reason we are using like this. Okay, and one more thing is hexadecimal upper, okay, equal to 0x AAF. Okay, this is also a valid one. You can use small x or capital X. Then the last one is binary, right? Integer binary literal equal to 0b101. Okay, the same way integer binary upper literal upper equal to 0b101. So this is how we can use. Fine. So to access all these class level variables, we have to create instance. Okay, so I'm going to say test, whatever name you want you can take. Okay, just I'm saying the object name as test. Okay, so here the term test, okay, sometime we used to say object, sometime we used to say instance. Okay, if we say object or instance, both are same. Okay, so don't get confused with these terms. Okay, right, so we can say object of the class or instance of the class. Okay, now we need to access all those things, right? Just out test dot decimal literal octal literal hexadecimal, then hexadecimal upper, then binary literal, I'm going to say binary literal upper. Now I'm going to run this. See, these are all the values. Float literal equal to 10.235 f. Okay, and the same way you can very well specify float literal exponent equal to 1.235 e1. So this how you can very well specify it in a scientific notation. Okay, fine. So if you try to print those values, okay, now try to run this program and see. Oh, sorry, 0. Okay, if you run this, you can get the same output, right? So this how you can use the exponent also. Okay, so that's all about literals. For ending this video, just I want to say, like, the literal will talk about the values. Okay, the values, if it is an integer, then we have 4 different types of values. If it is a float, we have 2 different types. So I hope you have some good idea about literals now. If you have any questions, please feel free to put the comments so that we will have a look and we will try to revert back as soon as possible. Thanks for watching our videos. Please subscribe our channel for more videos like this. Keep supporting us. Thank you.